What is the value of b plus c? Statement 1 tells us that AB plus CD plus AC plus BD equals 6. So I'm going to do a little reconfiguring of this. I'm going to switch the order of the two middle terms. You're always allowed to do that in addition. Addition is commutative, which means that you can switch the order and it won't change things. The first two equations I'm going to factor out a factor of A. In the second two terms, I'm going to factor out a factor of D. And it turns out that what I factor out in both cases is BC. So now what I'm going to do, this is even trickier, I'm going to factor out a factor of B plus C. And what I'm left with is A plus D. This whole procedure is called factoring by grouping. And it would be a good thing to look up in an algebra book if this is something that's completely unfamiliar to you, factoring by grouping. Well, now I have a much neater expression, but now I want to find the value of BC and I don't know the value of A plus D. So even after all that work, statement number 1 by itself is insufficient. So now here's the really hard thing. We have to forget entirely about all the work we did in statement number 1. Statement number 1 does not exist anymore. Statement number 2 comes along and just tells us A plus D equals 4. Well, that by itself tells us nothing about B plus C. So that by itself is insufficient. But you see where this is going. Now we combine the two statements. Well, now if we know that AD equals 4, then we'd get 4 times B plus C equals 6, and we could solve for B plus C. So combined, the statements are sufficient. This means the answer is C.